Hello, everybody. We're going to host a web seminar today on TestLab Neo 2306. And one of the new functionality is modal MAC correlation. So I'm going to show that today. And then I was going to do 3 demos, and I'm going to show this all in the software in TestLab Neo. So what's new in SimCenter TestLab 2306? This release came out in July, and we've added a task for modal correlation, and it can be used to correlate any type of modal model. So I put some notes in here that normally it's test versus CAE, but it could also be used for test versus test versus operating deflection shape or operational modes, CAE versus ODS or operational modes, or even CAE versus CA if you have different design iterations. And here's a screenshot of it. And I have one slide here on a new feature we put in TestLab 2306 that's kind of modal related. This works in Neo as well as TestLab Classic. And basically what we can do now is we can drag a mode set directly into a display. Or if you're in Neo using the pivot preview, you can highlight the mode set and it's going to preview. And then when you're in TestLab Classic or TestLab Neo, you're going to see these scroll bars. So within a picture, you can scroll through the modes with these little arrows. Or if you right click in the background and go to main mode or overlaid mode, you can jump to one of the modes directly. And that's not TestLab Neo only, that's both in Classic and Neo. So the mode sets are now supported in all of the geometry displays. That's kind of a nice feature I thought I'd share. We decided to put modal correlation in TestLab because it's a little bit different use case for test users compared to CA users. So we wanted a way to quickly compare models from different conditions, whether it be test or CAE, and we needed to have a mechanism to map the DOF or the nodes not mapping between the different mode sets. And that can be test in CAE, which is normally done, or maybe your operational deflection shape has a different node than your mode set does. So we can handle that. We wanted to support any different type of mode set combination. We wanted to be able to map by DOF ID or node name or proximity. So we can put a geometric tolerance around the nodes to do the mapping. And we wanted a way to interactively align the model. And that's a geometric alignment. So quite often you get data from test and CAE, and if you would have put the geometries on top of each other, they don't match. Sometimes it's in a different XYZ space. Sometimes it's a different unit, which results in a scale, or sometimes one of the coordinate systems is rotated. So we needed a way to manage that. A benefit to do it in TestLab is we compare all the modes in the same application. We've got some quantitative correlation indices like the MAC to look at results. And then we can verify the results before you go into more detailed analysis. So here I'll focus on TestLab. And as far as data management, we can browse through the active project or we can browse through this PC. And we're going to set the working geometry, which is normally your test geometry. And you're also going to set your working mode set. Then we'll go to the other mode set in geometry and set it to the reference mode set. That would normally be your CAE, as well as set your reference geometry and reference mode set. So I'll have to set these 4 things to define what is your working geometry, what is your reference geometry, what is your working mode set, and what is your reference mode set. And normally the working ones are TestLab, or the ones you're not changing. And the reference would be the ones you might need to rotate, translate, and scale. For the modal correlation, a blank project could be used. So I could start with a blank project, which I'll probably show today, and then browse through this PC to find both my test and CAE data. Or I could start with a test project with the geometry and mode set in it, with the geometry and mode set in it as a working geometry, and then I could browse through this PC to find the reference geometry and mode set. That's a CAE here. I could also open a TestLab project that has the CAE geometry and modes in it and use that as my open project. And then I would browse through this computer to find the test as the working geometry and mode set. I could also have a project, and I'll have an example of this today, that has both geometries, test and CAE, as well as both mode sets in it. And then if I save a project, it may look blank, but when you go back to modal correlation, it's asking you to open the links to the working and reference geometries, and then it loads both geometries, both mode sets, and brings up the MAC calculation automatically. So I'll show that as well. Okay, so I talked about this on the previous slide. I can right-click on a mode set or geometry to set it as a working geometry or mode set and a reference geometry or mode set. The modes can come from anywhere. So experimental modal, operational modal, order-based modal, operating deflection shapes, or from finite element model. And these FE modes can come from Universal, SimCenter 3D, ANSYS, Nastran, and Abaqus. In case of the mode set, you have to go and actually find the mode set inside the CAE file and set it as the reference mode set. If you're working in TestLab, picking the processing set's okay. So in TestLab, you can right-click on the processing set or the mode set, but for the FEA modes, you have to right-click on the mode set to set to the reference mode set. Doing test FEA comparison, we usually set the FE modes to the reference set and the test modes to the working set. If you're doing a modal decomposition, which this tool also supports, you would set the operating deflection shapes into the working set and the modes you want to use as a linear combination as a reference set. So normally you would put the working modes as your ODS and maybe your TestLab modes from a modal test or your finite element modes as the reference set. And then we can break the ODS modes down into linear combination of the reference modes. There's an automatic phase alignment. So after you do the correlation between the working and the reference modes, test and CAE, I can click on a value in the MAC table and then start animating. And by default, we auto synchronize the phase. So we're going to look at the largest deflection on the test and the largest deflection on the CAE and use that to synchronize the phase. If you don't like that, you can turn auto off and there's a slider where you can type in whatever phase you want to synchronize the two mode sets. You can also do model alignment. So here we've got an exhaust. This is going to be one of the examples. And you need to pick at least 3 node pairs, and then we can do the alignment. If you pick more than 3, we're going to do a least squared fit. So here we have an example where we did the beginning of the tailpipe here. We've got the exit of the tailpipe, so we've got 2 coming out of the tailpipe. We found the corresponding node on the finite element model, 2 nodes on the CAE model, and then we also picked 4 nodes around the muffler on both of them. And as you're picking them, they're red, and after you accept the node pair, they turn blue, and we can see the list of node pairs here. And then we can look at the transformation matrix, and here I'm going to show I can actually import these 7 nodes if I have them. So you can click them from the display if you don't know, or you can create a text or CSV file if you know what the nodes are and just import them. And then we'll see the deformation here. We've got a scaling factor of 3. One of the units must have been messed up with the CA model, and we had to fix that. And then we had a translation about X, a little bit about Y, a translation about Z, and then rotation as well. And these are all editable. So if you know, for example, this is exactly supposed to be 60 degrees, you can just type in 60 and hit OK. So all of these fields, the scaling factor, X, Y, Z translations, and the 3 rotations are editable. After you hit OK, you're going to look to see how many degrees of freedom are mapped, and then you can look at the list. And then you can see if you mapped all the degrees of freedom after that spatial orientation. And then there's going to be 2 different ways to look at mapping the nodes between the 2 working modes and reference modes, or the test and CAE modes, either by node name or by proximity. And if you're using it by proximity, you're going to type in a geometric tolerance in meters and use that to find the closest nodes. And then if you list those nodes, you can see that here we're mapping exhaust 1 to 1629 in the XYZ direction. Here, this measurement only had Z direction. So this location must have been a single axis Excel and exhaust 151 and 11185. So we only mapped the Z direction. If we had rotational degrees of freedom on our test data, as well as the CAE, it would map the rotations as well. Then I'm going to do 3 demos. I've got a plane, which is showed here, where I have test on the left and finite element on the right side. And here, the node IDs match, and they're in the same geometric space. So it's really easy to do this map between the 2. Then we're going to do this Simrad vehicle. And now the node numbers don't match, but it's in the same geometric space. So we've got a little bit of work to do. And then here we have the most work. where the node names don't match, and they're actually in different spaces and scales. So you can see the XYZ location is not the same. Before I jump into TestLab. So I'm going to go, and I have a quick access folder here, say, for my NeoMac calculation. So I'm going to go to that folder, and I've got some data, and I'm going to do a plane first, and I've got everything stored in a TestLab project. So this geometry here is my test wireframe, geometry 1, and geometry is my finite element. So I'm going to go to modal correlation, go to that plane, go back to that same project, go to geometry 1, and set it as my working geometry, and it shows up on the left side. I go to geometry here, set this as my reference geometry, it shows up on the right side. And then I go to section, go to my test modes, right click, and set those as my working mode set, populates here. Go to my finite element model, right click, set that as my reference mode set, and they show up on the right side under the reference set. Okay, and then it did the AutoMac already. So here it found 162 nodes matching, so it mapped all 162. If I wanted to look at the list, I can see the nodes exactly match, which is why this was so easy. So you could actually do this in classic TestLab as well, because the node names already match. But you can see here, it's very quick. I can step through, and I can start to animate the test modes. And on the right side, I can animate the finite element modes. If I want, I can look at the working AutoMac. And this is a Mac of the test modes, and I can step through and see these if I want. And then if I want, I can go to the reference AutoMac. Now these are the Mac on the CIE modes, and then I can start clicking through those if you wish, and they'll show up on the right side. Or I can go to the map between the working and the reference, and then I can start to click on these items in the Mac table and start to see my test mode on the left side and my CA mode on the right side. If I want, I can go to mode pairing, and I can see based on a 70% threshold, it found two modes, mode 1 and 2 and mode 7 and 11. And I can also highlight in that table, and it'll find the corresponding item in the Mac and animate it. If I want, I can drop this down to maybe 60. So now I picked another mode, and then I can highlight that and it should animate that. Okay. And then if I want, I can save this. Close it. Okay, so it's saved. And then I can close it. I can go to a TestLab again. TestLab Neo. And I'm going to open it up again to see what happens. So I'm going to open it, go to plane correlation. And then it's going to look like a blank project initially. Okay, so then I go to view data. You can see this is the project, and it really doesn't look like I have anything in it. But if I go to modal correlation, it's asking me, do you want to load the previous working and reference sets? So I'm going to say yes. So it's syncing. And now it's going to load the test geometry, the finite element geometry, find both mode sets, and bring up the Mac table. And then I can start to animate these again if I want. And that's stored in this information here, down here. So down at the bottom of the tree, I can see what items are being used. And if you wanted, I could always remove the set, or I could go through this PC and just add another working set and it would replace this one. Same thing, if I wanted a new reference set, I could go and find a new one and just say add to reference set, or I could remove this one first if I wanted to. Okay. It's a link to the original file. This project really has nothing in it except links. So let me close that one and let me do the second demo. So that one really didn't do a whole lot as far as using any of the correlation tools. So now I'm going to work on this Simrad, which is this test vehicle we use. So I go back to this quick access folder, go to my data, and go to the Simrad here. and go into this project. And again, this project has a test in CAE. So I'm going to right click and call this my working geometry. I'm going to call this my reference geometry. And then I want these 2608 Polymax real modes. Those are my working mode sets. And then go to my finite element processing here. So I copied and pasted this into TestLab, or maybe I did automatic reduction. And then I can set my reference mode set. So the working mode set showed up on the left. Reference mode set will show up on the right. I can click through these. I got a warning that the dots were inconsistent. Let's see what that says. Response dots are not consistent. Reference dots are not consistent. And you can see it has 0 of 302 mapped, but didn't map any of the nodes together. So now I'm going to go to, rather than by DOF ID, I'm going to choose proximity. And then by default, it's doing it by 0.01 meters. And it found 296 out of 32. And if I wanted to go a little bit coarser, rather than 0.001, maybe I can go 0.001, so I'll do a little finer. It was 296 initially. And then if I go to 1 millimeter instead of 10 millimeter, it's going to drop down a little bit to 292. So I lost 4 degrees of freedom by going from 10 millimeter to 1 millimeter. And if I go to the list here, I can see this list of the mapping. So the left side, I can see traditional naming conventions for test. And I can see the reference nodes, and I can see I mapped XYZ for all these locations. Then I can click on these terms in the MAC value and animate them side by side. If I want, I can turn auto off or just manually grab my phase here. If I need to synchronize them, I can click auto. I can turn on my mode pair table again, so turn on mode pairing. So I found 8 pairs of modes. If I wanted to animate one of these, I just pick the mode pair. I can scroll over to the right to see what the MAC values are. Okay, so I can click on these, animate them side by side. It finds a corresponding item in the MAC, or you can just click in the MAC and animate directly from the MAC. If I want, I can change this threshold. Maybe I want it to be 80%, for example. So found 4 modes there. And if I wanted to change the frequency difference, maybe go back to 70. And then maybe I want to say I need to have within 5% frequency difference, or maybe 10% frequency difference, okay, or even 20%. So depending how close the 2 frequencies are between the 2 sets of modes, you can find more mode pairs by decreasing the MAC or increasing the frequency difference. There's some settings here. So if I rotate a picture here, they both rotate. And that's because I have linked displays on. So if I unclick that, now they're unlinked. So now if I rotate one of these, they don't rotate together. And if you want, I can link the 2 views again, and then they should both rotate together. Standard stuff, I can go ahead and maybe you don't like the coloring. I can turn the coloring off. So I gotta do it on both displays. I can add node names, I can add node markers, all the standard geometry display stuff. We remove the settings here, so you're not gonna find the animation settings here as well. That's hiding up here at the top under display because we want the 2 displays that have the same settings. So if you need to add or reduce a delay, I can decrease the delay that way. Or I can also add more frames per cycle, so I can slow it down that way if I want. So we can either add a delay between frames, or we can change the frames per cycle to change the speed.
There was one question, Kevin. It says, are there 10 nodes not mapped in the table?
Yes. And you could see, you'd have to look at both the CAE and the test to see if there's points off in space that don't correspond. Or you could try to decrease this tolerance. So I think it was 296 if I had 10, So what if I go to 20 millimeter, for example? And that kind of waits, and you're going to see this DOF gets updated, and then it'll update the MAC and the mode pair table. So there, okay? So if I choose a tolerance of 20 millimeters, and then you'd have to look at these MAC values to see if that helps you or hurts you. Good question. I talked about the working sets at the bottom. So here in the quick access, these are basically links to the bottom. So down here, I can see what working sets I'm using, what reference set I'm using down here. If I wanted to do modal decomposition, I could decompose these test modes into the linear combination of these CA modes. And that's done by this decompose button here. So I can see this first one is 40% of the first mode. And then I can see these decomposition values, and you can animate them. And you can see the rest value very similar to how TestLab Classic does it on modal validation. And now I'll go to my third example. And this is the exhaust one. So if I go to this folder again, and then now if I go to the exhaust data, and we've been using this database for a long time, I can go into my exhaust data here, and I can set my working geometry. And then I can go into my test modes, and we test it to 200 Hertz. So I can set that as my working mode set, and it populates the left side. And then I can find my finite element data. And here I have it in an Astron OP2, just to show you that works. And then I can set that as my reference geometry. And go to my mode set. And here, if I go to the processing set, this doesn't work. This is where I was talking about. You can set a processing set in the test lab as my working or reference mode set, but that doesn't work in the finite element models. So we actually have to highlight the mode set and set this to the reference mode set. Then they'll populate over on the right side. And now you can see that the two geometries are different scaling and actually different orientations. The XYZ is different. I can still click through and animate these if I want. So I can animate these if I wish. And now we have to create some mapping. So let me stop this. Okay, so that way I can pick nodes. And I'm going to rotate these a little bit. Oops, I got to unlink my views. And zoom a little bit. And I'm going to try initially just picking nodes at the beginning of the tailpipe and these outlets over here in the same corresponding points here if I rotate them the same way. So so that's got a curve to it there. Let's try that. If I get it wrong, I'll pick different nodes. So then we come down here at the very bottom and we can pick mapping pairs. So I'm going to click a node here, turned red. Click a node over here on my finite element side, it turned red, and add node pair. And now they're blue. And then I can pick a node here and pick a node here. And then say add node pair. Then I can click one here. And I can click one over here somewhere. Add node pair. So here at the bottom right, I have 3 node pairs. It's green because I need minimal 3 node pairs. I can keep adding more if I want, or I could hit accept. And you can see I've got 0 of 56. We just did the alignment. Oh, I gotta change this to be proximity. So it's looking for them. Some response stops has been removed. So I found 20 of 56. Yeah. So if I go to my transformation matrix here, I can see what it is. I'm going to just import nodes that I know work. And I have them both in text and CSV. And I can see these 7 nodes I know work very well. And I had spent more time picking the 4 corners around this exhaust, corresponding here, made sure I was on the same top surface on both of these, and make sure that these 2 tailpipes are oriented the same. And then I can click default transformation, and then this has changed a little bit. And now if I hit OK, You can see it's rotated a little bit better. And we'll see if this improves. So now I've got 15 of 56, so I think my tolerance is off. So maybe I was good before, but I just had that tolerance to 1 millimeter from the last example I showed. So now this is going to be, there we go. Now we have 53 of 56. So I'm not getting that last node. So if I go to 0.5 here, 0.15, now I think this will be 56 of 56. I'm missing one node, XYZ. So I'm mixing 3 DOFs. And now if I go to our tolerance of 0.15, I'm getting all 56 DOFs. And I can see the correlation is pretty good. I've got the rigid body modes in the finite element model, but not the test. So that's why it's not truly on the diagonal. But I can click through and look at these. I can still do my mode pairing table. And then if I want, maybe I want a threshold of 80. And then maybe I want to have a larger frequency difference. Maybe say 10%, or maybe even 20% difference in frequency. Okay, so I picked up another one. And then if you scroll this over, you can see the frequency differences of the delta F in frequency. So this is 17 hertz difference at 117. So that's why I had to go to 20% to find this one. Then I can see the MAC values over on the far right side. So this is the list of the node mapping. So I can see this transducer 152 only had Z in the test data. So it didn't map X and Y. This one here had Y. And then the other locations pretty much got X, Y, Z. Can you override a node mapping if there's 2 nodes right next to it? Tim, you would just have to make sure you pick the specific one. So when I was picking my nodes, I kept mixing up these 2 tailpipes. So you just have to zoom in and make sure you pick the node manually. So thank you very much for watching our correlations seminar today. Thanks, everybody.